We're going to do liquid dispensing using the Echo 650 acoustic dispenser. We're going to do it using the Echo Plate Reformat software. This is the software that will bypass any need for the robot and just speak directly to the Echo. It asks you for the IP address of the instrument. It's 192.168.99.71. You say connect. That's just because you could install this on a platform with multiple devices, and then you would need to know which one. It opens this window. It could be alarming that there's like nothing there, but don't be scared. You just have to say either new or open, depending on if you're opening an old protocol or you want a new one. Let's just say a new one. And so now it opened all of the things. So there's a few things you need to specify: your source plate and your destination plate. The source plate only has 3 options. There's only 3 types of plates that are compatible with this device. There's 1536 LDD plates. Those look like, do I have an example of this? This is a LabSite 1536 well low dead volume microplate. It's a dirty one, but that is what that is. Then there's an option for the 384 well low dead volume plate. That looks like this. It has these diamond shaped wells. And this is also made by the LabSite company. And then the third option looks like this. It's a 384 well polypropylene plate. So the settings often just say PP for polypropylene. These have a bigger well and also a bigger dead volume. So depending on your application, you pick whatever your plate type is going to be. Let's just say 384 PP. Well, yeah, that's what your library is actually going to be in. And then you want to say which kind of settings to use. This depends on the nature of the liquid being transferred. Most people are doing DMSO. So you click on this 384 pp DMSO2. That's the default setting for if you're transferring DMSO. That would be true if you're doing compound libraries. If you were doing an aqueous solution with surfactants in it, so examples would be cell media, because the high FBS concentration acts like a surfactant, or PBST, something like that, then you would use this setting. The S there stands for surfactant. If you have an aqueous solution with something very viscous in it, like glycerol, the G there's for glycerol, then you would use this setting. Or just any other aqueous solution, you can use this aqueous CP. This is the most adaptable protocol, so if you're ever not sure, just use the CP one. It's meant for making crystal trays. That's what the C stands for. But that protocol takes extremely long. It spends a bunch of time focusing each individual well so that it can be maximally adaptable to different liquid compositions. So we're gonna do DMSO. And then we set what our destination plate is. This one is a lot less specific. It's basically just programming it with the geometry so that it will know where to place the plate in the holder. And we have many options, and you can add and customize plates to the list. You can even dispense to multi-plates, you can dispense to membranes, you can dispense to anything that fits in the holder. So for your experiments, when you do your plate reader assays, you're gonna probably, like for your 384 well experiment, you'll have something like this plate. This is a Greiner 384 well polystyrene plate. So your plate will be something like that. And then you get to choose, do you want to just replicate the whole plate so that your source and your destination are just going to be identical? It's called stamping. And you can do the full plate, and you can say how many nanoliters you want. So it will literally just, everything from the one plate will be in the exact same location on the other plate, that many nanoliters. The other option is to do custom. And I'm just going to demo that very quickly, but it opens this window where you can say, I want this compound to go there. You can go anywhere, and you can say how many nanoliters you want. So say I wanted 10 nanoliters of that to go there, and then you say add region, and you can build a protocol like that. You can say, okay, now I want that one, or maybe I want a replicate at a different volume, so the same one to go next to it, and instead of 10 nanoliters, now I want 100 nanoliters, add region, you know, and you can build whatever sequence you want. So it's very adaptable. The software was, or this device was originally designed for printing, so you can imagine having ink cartridges and then being able to print any color in any pixel. You can also select a whole region, and then replicate that onto the plate, you know. You can also, if you want, this is called transpose. So notice how this is rotated 90 degrees. If you click transpose, then it will let you add a region where, you know, it's going the other way around. There's some situations like avoiding edge wells where you might make use of that. And then, anyway, so you build up your protocol, and when you're ready to run your protocol, you would save it just by clicking the save button. I'm just gonna call this temp. Oops. Temp. No, that's not the folder I want it to go in. So the protocol should be saved in a folder. If you go to the desktop, there's a shortcut to the protocols folder, and this is where they're all saved. It's the C drive LabSite Echo protocols. And so you just save your protocol, and then you click on this triangle for run, and then it will ask you again, do you want to run full plates like in the protocol? Another option is to make a pick list where you would upload an Excel spreadsheet instead, but we're using the protocol we just designed. And then you say how many source plates you want. So this would be like if you have multiple compound library plates that you want to dispense from. You can also say how many destination plate copies you want to make of each. So if you had, you know, 3 cell lines on different plates, then you might need 3 different plates. And you can click simulate and play, and this will simulate the sequence that it's going to go through when it does the real plate, and it gives you a drawing of what it ended up looking like before and after the transfer, with a number corresponding to how many times that well either was used, either got stuff or provided stuff. So like this well we used twice, we used it there and there. And you can also hover and see how many nanoliters were used. So that one, you know, 110 nanoliters were used because we put 100 there and 10 there, so, or 10 there and 100 there. This is very useful for just checking to make sure you made your protocol the way you want it. So when you're happy, you can run it again, and this time do it for real. I recommend first running an experiment where you just dispense some dye so that you can doubly check that your plate looks like what you're expecting it to look like. And then you'll hit run, and that opens this window, and you click on start at the bottom right. All of these things should be green, indicating that the device is good. And then it instructs you to please insert your source plate. So that's when we're gonna put the compound plate. And I think I said for it to expect the 384 pp plate. That's what most of our compound libraries are in. So we're going to insert that to the device. If your compound plate has a seal, then you definitely want to remove that before attempting to dispense from the plate. And you place it in this holder here. The corner A1 should be in the, well, if you're facing the instrument, it's the top left, but if you're standing where we are, then it's like the front left. There's a reminder picture here just to make sure you know where A1 needs to be. And make sure that it's positioned in the correct spot. If it's at all off, okay, well, if it might just be so off that it falls through the hole. Anyway, I can't even simulate it being wrong, but if it was in wrong, I always just give it a wiggle. If it wiggles like that, then you know it's in the right place. And that's true for like most microplate handling equipment. It just, that kind of wiggle tells you a lot. So we're gonna say, okay, we inserted the source plate. And so then it takes the plate into the device. It's deionizing the plate on the way in, that's why it's so slow. And then that cone of water is starting to circulate into the plate. It opens the next holder that's going to be for the destination plate. So now the software is telling us, please insert the destination plate. Over on the software. So it says, please insert the destination plate. Now we're ready. So again, it goes in the holder with A1. You know, it's the top left if you're facing the instrument, or if you're standing to the side here, it's your front left. And you give it a wiggle to confirm visually that it's in the right spot. And again, there's no lid, there's no seal. You do want to make sure that the volume of liquid in that plate is not so much that when it tips upside down that the liquid could drip out. So when you click OK, you'll see the plate actually flips upside down and then goes into the instrument. So that's why you don't want the liquid to drip out. And now it's doing the transfer. Let's give you a progress bar. This was very quick because we only just transferred a couple of things. So there's our destination plate. It says, please remove destination plate. Yeah, it's empty because we were just dispensing from an empty plate. You click OK. It's going to put that back. Bring out the source plate. This one you may want to seal. This one you may want to put the lid on, you know, depending on what it is that you're doing. And so please remove the source plate. Okay. So now it's done. It says protocol execution complete. Before closing this window, it helps to just check that the door is closed on the device. So see that white door, that's good. If it's not closed, there's a convenient button here in the corner that says open door. And then once you've closed the door, or it would say close if it was open, then you close this window and then we're back here. And we're done, so we can close this software. You can leave the computer on, you can leave the echo stays on all the time. And that was acoustic dispensing.